This episode is brought to you by Ardan Labs Education. Sign up today to learn advanced concepts in Go, Docker, Kubernetes, Terraform, and more. Visit ardanlabs.com/education for more information.
Welcome to the Ardan Labs podcast. Our special guest today is Daniel Whitenack. Woo!
What's up?
Daniel, I'm so excited to talk to you today, dude. Where are you coming from today?
Lafayette, Indiana. I'm here in my apartment. Lafayette, for those that don't know, is sort of between like Chicago and Indianapolis in the Midwest of the United States.
So how far away are you from South Bend?
So it'd probably take like an hour and a half, couple hours to get there. Yeah, because I know you've got some passion for the Fighting Irish.
Yes, I do. And this year I try to go to one game a year. I haven't been up to South Bend in a little bit, unfortunately. Their schedule's a little tough for me this year to go. But I was thinking about seeing the BYU game in Vegas because my wife hasn't been to Vegas, but I haven't committed to like rooms or tickets yet, so it's probably too late. But the Irish like to travel.
I'm going to Dublin for the first time at end of May. So yeah, let me know what to do. I assume you know. So
I've been to Dublin one time because I did some client work there, and I almost got to go again because the Irish were going to play Navy a couple of years ago, and obviously all that went down. But I'm dying to go to the Jameson factory over there. I love Jameson, but I did see the Guinness factory, so definitely don't skip the Guinness factory. That's kind of cool, and obviously get out of the city because once you see the countryside in Ireland, it's like magical. So you got to do a little bit of that. Are you going for work or are you going for fun?
Going for work for a conference. So the Association of Computational Linguistics has their big conference at the end of May, which is it's kind of like one of the main AI natural language processing conferences every year. So it's at the end of May. We're presenting a paper there. So yeah, it should be fun.
Yeah, try to say that 3 times fast, okay?
Yeah. ACL, it's a little bit easier to.
So you're going to be on stage discussing a paper?
A PhD student that I am helping to advise, he's presenting our paper. So I get the fun job of just sort of like being along for the ride and getting to talk to people in the hallway and all that stuff. Yeah, exactly. It's nice.
With no stress. That's brilliant. Okay. Enough little fun catching up there. Give everybody the 2-minute drill on what you're doing today.
Yeah, sure. So I'm a data scientist. I work for a faith-based nonprofit actually called SIL International. SIL works all around the world. Over like 100 countries doing all sorts of things related to language. So our vision is to see people flourishing in community with the languages that they value most, which means all sorts of things. So like literacy work, multilingual education, early childhood education in the mother tongue, language survey, language development, like all sorts of things. But I specifically work on a team that is trying to extend the benefits of AI and natural language processing types of technologies into more and more languages. So if you think of like something like speech recognition, for example, or like the things that happen in your Amazon Alexa, those are mostly supported in commercial platforms for like maybe 10 to 20 languages, but there's 7,000 languages spoken today in the world. So basically there's this whole giant population in the world that are sort of getting like even further marginalized because those technologies aren't like helping them flourish in the digital sphere. So those are the things that my team works on, working on things related to translation and machine translation, speech technology, basically all of those sort of AI-like technologies that are starting to impact our life, trying to make sure that those are inclusive of more and more languages.
Okay, I got to ask this question now, even though I don't want to. Two questions here. One, where is the funding coming from for all of this work? Because who's got the incentive to fund this? Because I think this is important work, but that's always an interesting question. And then second, when am I going to get my Babel fish so I could talk to anybody all over the planet?
Okay, yeah. Well, if you give us funding specifically for the Babelfish, we'll start work on it right away. Now, I'll actually come back to that because there's some interesting things there. But yeah, in terms of the funding, I mean, we are a nonprofit, so there's a variety of like foundation and like private individual funding that comes into SIL. But we like have partnerships with all sorts of different nonprofits all over the world, but also like governments and like multi-country organizations. Like we do work with UNESCO and the UN, and governments like related to work. So it's sort of a combination, either like foundation funding that's specifically geared towards like language related projects, or sort of professional services and contract work as related to language, either from like governments and institutions, or from like even commercial companies that are trying to do something related to like multilingualism or languages. And then we also do have a few like strategic products that we use internally, but are also licensed externally or have some commercial side that's a stream of revenue into SIL. So there's a data set and a product called the Ethnologue, which is basically information about every single language in the world. So where is it spoken at? Like, what is the population? What writing system script does it use? What resources are in that language, et cetera, et cetera. All of that's in the Ethnologue. And of course, that's a really valuable like service. And so we use that internally, but it also takes a lot of work for us to like actually accumulate and maintain and curate that data. And so there's a lot of universities and other institutions, like even tech companies and stuff, that license that data from us. So.
Okay, one last question. We're going to get started here. This would suggest to me that the more and more of these communities have access to smartphones, because without smartphone access, your tech isn't really going to be viable, right?
Yeah, so it's really interesting, actually, if you look at like countries in Africa or Southeast Asia or these other places, actually people's sort of first computing device is their phone, which has like a lot of interesting implications, because things like speech technology and voice, like both because their first computing device is a phone and because there's a lot of like oral based cultures in these countries, like voice and speech technology is a very natural thing for these new users who are coming online. It's very natural for them to use that. And kind of important for that to exist for their languages. So yeah, there's tons of people coming online now on mobile devices. But then we're even doing work like, you know, people are taking tablets or laptops like out on the canoe back in like through the rivers of Papua New Guinea to do like language transcription and like documentation work, even in an offline context. So this like offline edge computing device sort of scenario is also very interesting for us, because these places have like not that reliable of internet. And so even if you are connected, you can't just like run all your models like on a beefy node in the cloud. A lot of times you're kind of figuring out, okay, well, what resources does our application use, and how could we deploy it on a laptop and run it without a connection to the internet, things like that.
I can't believe you're dealing with that. We were dealing with that in the 90s when we wanted to gather patient data at the home, and we would have to capture it all, and we would ask the nurses to plug the device in, which they would forget to do, right, to the phone line so they could download. And my brain's like, okay, these are solved problems. No, they're not, Bill, because now we're all over the planet.
Well, and actually, there's sort of like a flip-flop in some ways. Like people have had all these like privacy and security things related to AI applications specifically. And so there's a big push for this thing called like federated learning, where actually like data that you're processing in your model or that your model is trained on actually never leaves the edge, end user device, but you have ways of actually training models across in a distributed way across devices, so that actually like pictures that I'm taking on my phone are never sent to like, a major tech company to train their model, but they can still train a model on those images in a sort of differentially privacy conserving way, which is quite interesting. Yeah.
Okay, last thing, and we're going to get started here. I don't like Siri. I turn it off. Too many people around me think I'm crazy for that. Like, I just don't want to talk to the phone. Is that unusual, Daniel? Because that's kind of what you're trying to really support, right?
Yeah. So I would say that definitely is one of the kind of when you talk to someone about like speech technology or AI, that's one of the first things that come to mind. But actually, if you look at like, let's say, think about how like you flourish as like a human being in the digital sphere. Well, if you look at even something like Google Search now is driven in English by a backing AI model that's trained on a whole bunch of English data. And that sort of model is not available for most languages of the world. So even something as simple as like Google Search, or if you think about like autocomplete in your Gmail emails, like you have this cool, like, oh, it's going to complete part of what I say. Or like education, like a lot of online education systems are using like AI techniques now to help like guide a user journey and stuff, or like movie recommendations. There's just all of these things that like touch language in one way or another. And we sort of like take for granted because like, yeah, all of these things work in English, but the reality is most of those things don't work in like other languages as well.
That's fair. I think thanks to Veronica on Twitter, I hit the translate link button all the time. The more people I'm meeting from all over the world, I love that translate tweet.
Yeah, that's awesome. Yeah, it's cool.
And I have the Google Translate app because there's a family chat all in Spanish. And sometimes I'm just like, okay, I have to know what that person said. So I've gotten really quick at copy, paste, translate. So I get it. Okay. We're going to get back to that. But this podcast is really supposed to be about you. And I want to kind of talk about you here. So to start that off, I'm going to age you a little bit. What year did you graduate from high school?
2004.
Okay, 2004, Daniel is a young 17, 18-year-old, okay? Graduate like 18. So 2004, graduating high school, I'm guessing in Indiana.
No, actually, I graduated high school in near Dallas, Texas. So I grew up in Colorado, actually. So I grew up in Colorado, and then my family moved down to Dallas for it was my like junior and senior year of high school.
What? That's the worst time to move, dude.
It is the worst time to move. And
oh my goodness.
So and I didn't love Texas. I have nothing against Texas now. Actually, SIL headquarters is in Texas, so I'm down there a good many times. But I just wanted to sort of get back to Colorado because that's where I felt like my home was. So after I graduated high school, then I went to college back.
All right, but I don't want you to go that quick, but that's a big culture shock going from anywhere to Texas, I think. And again, not anything anti-Texas. It's a different culture, right? So
it is, yeah. No mountains, very hot. Different. I mean, also the different Yeah, it's a different culture. I guess that's a good way to put it.
It's a different culture. It's just like if you go to California, everybody's laid back. If you go to New York, everybody's in a rush. If you go to Miami, everybody's pretty much wants to party. Like there's reality and culture in these different areas, right? And so Texas, especially junior and senior year in Texas, because if you ain't playing football in Texas, like there's a whole nother kind of dynamic to that, right?
And I definitely wasn't playing football. I was I was the nerd on like Quiz Bowl. That was me.
All right, so here's my favorite question to ask. We really start the show off this way. I want the first thought or memory that pops in your head when you think about working on a computer. What's your earliest memory of the computer?
I mean, there's maybe a couple things. Like at home, it was probably like Flight Simulator, Microsoft Flight Simulator. For whatever reason, like that really hooked me, and I like spent a bunch of time in Flight Simulator. So I remember like that distinctly. But then like actually digging into computing a little bit more was probably in high school. I got there's sort of this program, I forget what it was called, like computer tech or something. It was basically like the high school subcontracted out a bunch of their IT support for free to their students. So like you weren't paid, but you got like a class, right?
Was this in Colorado? This was in Colorado?
No, this was in Texas. Yeah.
Okay.
So like
before we go to Texas, before we go to Texas, was there in your Colorado high school any computer classes then?
Yeah, there was actually. I'm glad you mentioned that. I sort of like I haven't thought about this for a while, but there was like I think it was called. There were two things. I remember there was like a robotics club. I forget what the like robotics stuff was at that time, but it was like some type of robotics club. I was part of that, and then there was what was called engineering design. I remember there was like a way, like we went through this class as I think like middle school, early high school, where you could like design bridges and like test the weight on them. There were like programs to do that. And then like very basic sort of schematic drawing and that sort of thing. I remember that was probably one of the earlier things, which that kind of got me started thinking about engineering, I think. Originally, I wasn't really thinking about computers a lot. It was more like mechanical engineering was what I thought, like, oh, the like mechanics of things and like big machines. That was kind of what I was interested in.
Where do you think, first of all, I got to ask this anyway. I was so bad at Flight Simulator. I was bad at video games in general. Like, I'm not a gamer because I was so bad, but the flight simulators were even harder. Were you able to land that plane every time, Daniel, or you crashed the plane?
I mean, I got pretty good at it. I think also it's like something about this element of, I don't know how to phrase it. Like you're in Flight Simulator, you get the plane up. Like some people just like skip the whole flight thing and they're all about like the landing and takeoff. But like I would spend hours just like flying around like in the plane. And there's something about like, I'm the same way. So one of my hobbies is backpacking. I feel like just like walking, and like my wife finds it so boring. I'm just like, well, today, what are we going to do for 10 hours? Like, we're just going to walk on this path for 10 hours. That's fine. So there's something about that in my mind. Like I really, really enjoy that sort of activity. It's like,
it's a form of meditation, I think.
Yeah, something like that. Yeah.
You get to be lost in it. Like my wife laughs at me. My form of that is putting on the most brainless TV show or movie that I can find. That's my meditation time, where my brain does not have to be active, on anything serious. Where do you think the mechanical interests came from when you were in high school? Was it where do you think that came from?
Yeah, my dad was like a manufacturing engineering consultant. He worked for BF Goodrich for a long time, and then got into sort of like the consulting side, and always at home. So that was my dad. My grandpa was like, he was like a craftsman, woodworker sort of person. And so always at home, like we would always be doing like hands-on sort of craft stuff. So like building airplanes or rockets, or like doing some type of woodworking, or like whatever it is.
Yeah, don't buy that chair. We're gonna go make one. What are you talking about? I can make that chair 10 times better, right?
Even to this day, like I have those desires of like, well, I could buy this from the grocery store, like, but could I make that at home? Like there's like certain things like that. And usually it doesn't work out that great, but there's like that desire. I think that was bred from a young age. And so like that mechanical side of things was there. I think what I learned though was that I'm like a really clumsy person. And so like I can do that sort of woodworking type of stuff, but I'm not like the best at it. Like the hands-on like crafting.
Yeah, but that's muscle memory.
Yeah.
That's muscle memory, right? Like you didn't do it enough.
Yeah. So like I can do certain things, like also like I juggled in junior high and high school. I was really into that. And
you could throw
like
it behind
that,
your
like
back.
you're talking
How many
about,
balls?
it's like,
Okay, time out. Juggling is. I was only ever to get to 3 balls. I could do amazing thing with 3 balls behind my back, under the legs, but I couldn't go beyond that. Right? How many balls were you able to juggle it?
So
did you get to like 4 or 5?
I could do 5. I could do 5 on a board that was balancing on a pipe.
Okay. So you're athletic.
Yeah. Well, yeah, I think it's that like obsessive, like muscle memory, like accomplishing new, like the next trick sort of thing that like drove me. I was never into like organized sports. Because I'm a very introverted person, I think that sort of juggling side of things is like, I can progress this all on my own. I can go into a room. I can just do this for like 7 hours and I will get better. That like, that appealed to me. Whereas like the organized sports thing, then like navigating all of the like social elements of that, I think it was less natural to me as a youngster.
Can you still juggle? Because every once in a while when you got like a 8-year-old or 10-year-old in a room and things are kind of a little bit boring, I could just pick up 3 balls or whatever I can get my hands on, and everybody's like, what? And I can't imagine being able to go beyond 3. Like that's a fun little skill, right? Like if somebody says you have a talent, you can just start doing it.
Yeah, I still do. I mean, I can't do anywhere near what I used to be able to do, but I can still like do all of the basic stuff. And that's fun. Like, at a party or with kids or whatever, like you said. Yeah.
I mean, anybody can play the piano, dude, but can you juggle? So that's funny. So look, why do your parents move to Texas? Is it because your dad or your mom or somebody, like there's a new opportunity there and that's where you have to be?
Yeah. So my dad worked for this consulting firm that basically implemented, I don't know if you ever heard of Kanban, but it's sort of a similar type of like manufacturing optimization flow, like project management type of stuff in a factory. And he did that. And then that company actually went under. And so then he got a new job, and that took us down to Texas. So he's actually still, so that company, it was acquired by, I think, it was acquired like 2 times. Eventually it got bundled into Dell EMC. So it was like bought by one company, and then that company was bought by VMware, I guess. And then that company was then bought by Dell EMC. So he still does like stuff with Dell EMC. He works, I think he's like partially retired now. So that's what took us down to Texas.
You didn't fight at all? You were like, no, Dad, I'm not moving. Go. I'm staying right here.
No. Our family culture was, let's say, much more conservative in terms of feedback from from the youngsters. So yeah, that wasn't really within the realm of feedback.
No, I can see him say. So now I can see him say, Daniel, pack your bags. We're going. No, Dad. And he'd say, I know it sounds like a question, Daniel, but it's not a question.
Yeah. And like they, my I say the sort of conservative side, and that was true. But yeah, I mean, they were always part of why they moved down there, because they thought it was a really good opportunity for a family, and it was like very good in many ways as I sort of finished school and still have a lot of good connections down there. So
Right, but like your first day of high school down there as a junior, you know nobody. Everybody knows each other. I mean, that's it's just not easy, right? So, where did you end up you gravitating to? You said I forgot what you said you were focusing on over there for those 2 years.
Yeah, so eventually, this is kind of where that computer tech stuff came in. They had this like, it was a class, so there was a like hours during the day that you devoted to it, but it was basically like we did IT stuff for the school, and there was probably a group of like 4 or 5 kids that I got pretty close with in that, and then our teacher in that, he also managed a bunch of the IT stuff for the school. And he was a really great mentor in terms of like letting us try things, letting us get up into the attic and like throw cable through, and letting us take apart things and all that sort of stuff.
Yeah, I would have been too with the free labor. I mean, go for
I
it, man.
know. Yeah, well, he didn't want to get up in the attic. No.
I don't blame him. You know, today you couldn't even tell the kids to go up in the attic today with the liabilities that are there, right? It's kind of, sometimes I'm glad I grew up when I did, because you can't do that anymore. All right, so you start to have this affinity for computers. I imagine are you taking any programming classes, or this is all looking like IT?
So it was mostly IT at that point, although we did a little bit of like Visual Basic type of stuff. So there was a little bit, but I would say I wasn't really thinking about programming at all at that point. It was like, recovering passwords, or like setting up a new computer for this lab, or like whatever the thing is.
So that means you had access to the grading system, didn't you, Daniel? Come on, be honest. You had passwords.
Yeah. How do you think I how do you
How
think
do you
I
think I
made it this
graduated high
far?
So, as high school's coming to an end, right? You said 2004, right? And you're 18. It's 2004. High school's coming to an end. What are you thinking next? Are you thinking I'm going to go to university? I'm going to.
Yeah. Our family was always like, my parents always encouraged us towards college. So that was really what was in my mind. I know a lot of families aren't like that, but in our family, it was very much like, where are you going to college? Not like if you are. So that was always in my mind. And I knew that I didn't want to stay in Texas. I wanted to get back to Colorado, because that's where I felt like my home was, where I wanted to be. Um, in terms of like, at that point, I'm thinking of like very much engineering type of is like what I think I'm interested in. Um, and in Colorado and Golden, there's a school called Colorado School of Mines, which is just like science and engineering. That's the whole school, applied science and engineering. It's really well respected in terms of like the engineering circles, like civil, mechanical, et cetera, engineering. And so that's where one of the places I applied. I got accepted. It's kind of where I wanted to go. It's right on the edge of the mountains in Golden, really nice location. And so yeah, that's where I ended up.
I imagine that you were thinking about that school for a long time. Like that was your top. That was your number one.
So it as a kid, when we were in Colorado, we would go there because they have like a geology museum there, and it's free. And we could go there. And so I was already like, my parents and family was already familiar with it. So I think they encouraged it as well. And I knew it was like a cool place, and there were all sorts of like sciencey type people there, which seemed cool. So yeah, I was kind of, that was my number one as far as where I wanted to go.
And what ends up happening there? Do you graduate with your mechanical engineering degree?
No, I got so what happened is got to campus, and I think even before I started freshman year, I knew I needed a job because I needed money. So I got a job in the mechanical engineering department, working in IT because I had experience working in high school in IT. So I got hired into the engineering department to work in IT. And over the first couple of years I was there, I got my advisor, who is also in engineering. He said, "Hey, like, you know, you're doing this IT stuff, but it'd be cool if you could start working with my group because we've got all this cool like computer modeling stuff going on." And what they were doing is they were basically modeling the properties of atoms and molecules with computers and things like carbon nanotubes and stuff like that. And so I thought, oh, that'd be cool. So I did I forget what it was. It's like an undergrad research experience type of project with his group. And after that, I was kind of sold. So I switched my major from mechanical engineering to physics because really that sort of work was more related to kind of computational physics type of stuff. So then I was sort of hardcore in the kind of computer modeling physics stuff. And so for that last 2 years, I took things like, numerical methods for differential equations and like modeling computational chemistry stuff, and finished out with my physics degree.
Yeah, these classes sound like way over my pay grade. Just I can't even pronunciate half the words there. Was there any programming going on here, or was it all really like hardcore math? Maybe Math Lab. I don't know if that was around.
It was interesting because I think in the physics program, and I don't know if it's the same now, I assume it is at Mines, they call it engineering physics or applied physics. And as a result of that, they have this really interesting approach to the physics program that I think has really served me well all of these years in like the tech world, in that like they're all about not just like doing pen and paper sort of math and stuff, but like my mechanics class in the physics department, for example, we did all of our homework assignments in Mathematica, which is kind of like a notebook style programming environment. We did like all sorts of simulations. We had a summer course that was required where one whole module of that was like Linux and working at the command line. We had to take some programming. I took Fortran. That was my first like formal programming class. And so like tied into all of these pieces, like within the physics program, was very much a focus on like implementing things on computers, whether that be Mathematica, Fortran, MATLAB. I got really into MATLAB at that point. And so I'm programming a lot at that point in probably either Fortran or MATLAB mostly.
So what are you thinking in these say the last 2 years of university? You're doing pretty hardcore math. I love that it's a practical experience there, but what are you thinking you're going to do after university at this point? Is the next step now graduate school to do more of that, or do you feel like there's a place in industry for this same sort of work?
Yeah, to be honest, I had absolutely no idea. So I was like, that's part of the reason I think I ended up in grad school, is like, well, I just don't really know like what quote job I want yet. But what I did know was I really like the physics stuff. And I was also like, I sort of naturally like school. Even now, like I love being in classes. I love being like in the university environment. Like it's very appealing to me. We live in a university town. And so I was like, well, if I can do that for more years, that's great. And I think also maybe something people don't realize is on the technical side, like in physics or engineering, most of the time you don't pay for grad school. So you don't make a lot of money, but you sort of get a TA position or an RA, research assistant position. And most of the time, like, you're teaching a class and you're doing your PhD. And so as part of the teaching assistant piece, like, they're waiving your tuition and they're giving you a stipend on top of that. So like, it was a job in the sense that I was getting paid, but not this a sort of typical job. Like, it's so it wasn't that hard for me to decide, well, you mean I can do this for like 5 more years and I don't have to pay a bunch more tuition, but I can just have fun and do like physics things? That sounds like a good deal to me.
Yeah, and have a place to live and eat. Okay,
Right,
sign me up.
exactly.
And I
Yeah.
can learn more. So was it at the same university that you did your graduate work?
No. So I graduated from Colorado School of Mines, and the advice I got at the time was, hey, you want to do your PhD or your graduate work somewhere other than where you did your undergrad. There's like pros and cons to that, but I decided that I wanted to do that. That's how I ended up out here at Purdue University in the Midwest. But between my undergrad and grad, I did an internship in high performance computing at the National Center for Atmospheric Research. That's in Boulder. It's called NCAR. They have some of the like largest supercomputers that the U.S. government like has in national labs. So they do like all sorts of climate modeling, and now they do like AI stuff and other things on those computers. So between my undergrad and graduate year, I spent a summer basically benchmarking climate modeling applications on their computers. So they had just installed a new IBM supercomputer, and I was testing out like doing benchmark runs of their various applications on that.
What was that written in? I mean, we're talking 2008. Was that all written in? God.
A lot of it is Fortran. Yeah, I mean, like physics code, even nowadays, whether it's stuff running at CERN or there, wherever, a lot of it's been developed by like graduate students over time, right? So like, if you have a graduate student for 4 years, they're not going to like rewrite your whole code base in some other language. They're going to be like, oh, there's all of this monstrosity in like Fortran or whatever, and I'm going to wrap it with like Python scripts so I can work with it, but I'm not going to rewrite the whole thing. So there's a lot of that kind of thing going on.
So then I would imagine that, I never thought about this till you're saying it now, but then I imagine that the very first like gravity engines and things like that were written in Fortran, right? Because you need all of that kind of stuff.
Yeah, there's still a ton written in Fortran, and there's still in like the scientific computing world, even if you're using like Python or something like that, a lot of that under the hood is calling into Fortran. So like NumPy and these libraries that are used sort of ubiquitously in the scientific community, they're the reason they're fast is because they're calling into Fortran under the hood.
Wow. So normally the graduate work is like 2 years, right? And then you go after your PhD. Were you trying to, you just decided you were going to do a PhD right out of the box?
Yeah, it's different around the world, but in the US and in physics, typically if you want to do your PhD, you just go straight into it, and you sort of like, sometimes you get your master's as like a formality, but you kind of just enter the PhD program. The master's is usually like, hey, I want to get a master's and then I want to go into industry. I don't want to necessarily do a bunch of like research type stuff. I started, so that would have been 2008. I started my PhD and then I graduated end of 2012.
Okay, a few things here, right? Every one of my kids who have now basically graduated university changed what they wanted to. You changed, right? You went from mechanical to physics, applied physical, right? Physics. So I hear that story. I saw 3 of my kids go through that. But I mean, it took you 5 years. Is it? I'm saying it took you 5 years. I don't know how long it would take. I mean, but for those 5 years, you're working on your PhD. You maintained a love for what you were doing there. You didn't shift at all.
Yeah, I think I shifted I mean, I shifted less so. By the time I got there, and especially after coming out of NCAR and doing the high performance computing stuff, I definitely knew that I wanted to do like computing things. But I also had this really strong interest in like the physics and the like theoretical side. And so there was a little bit of a shift in that I got like my PhD ended up being sort of like half theoretical and half computing. Whereas like what I was involved in up to that point was like very much just computational like modeling.
And what was your PhD? What was it that you decided you were going to?
Yeah, so I worked with a guy named Adam Wasserman. He's at Purdue University here, not too far from where I'm at now. And he works in an area, it's called density functional theory. But basically what it is, it's a way to calculate the properties of atoms and molecules. And he did it in a certain way, which was sort of intriguing to me. There's a lot of people doing this even now, like to calculate properties of things for like drug discovery and other things. But he had this approach where it was like from first principles. That was like his approach, which means like we're only going to use the basic equations that we know to be absolutely true. And we're going to calculate properties of atoms and molecules from those without sort of like a lot of fitting. So now, and even back then, there's a way to like model these properties by just like running a bunch of experiments and training or calculating like properties based on all of these previous experiments you've run. And so what you end up with is a whole bunch of parameters that you've sort of fine-tuned to do a certain thing. Whereas we were kind of going more from the theoretical side. So I did shift more to that theory side, which is sort of interesting to me now because I'm working in AI and machine learning. And back then I was all about like, oh, we've got to calculate things from like the theoretical like equations that we know without these like extra parameters. And there were these people like using, oh, these people over here, they use like 30 parameters in their model. And these people over here use like 50 parameters in their model. That's crazy. And now like in my models, they have like a billion parameters. And I basically like swung the other way in some senses. So that world, that AI and machine learning world actually has impacted the world that I came out of as well, because it's been affected by that sort of shift.
It's like this idea that I want to be a purist in what I'm doing, and everybody else was, in certain conditions, taking certain liberties to get to the right answer, right? Which was a hack in your head.
Yeah, it's like, we're theoretically right, but we can't calculate that much. You're like fitting to all these experiments, so your thing won't work on edge cases. And like both are true, right? It's probably like if you have a balance of both perspectives, like with most things, it's not like if you go totally one way or totally the other way, it's the right thing, but you have to have some type of balance of those perspectives.
So you spend 5 years at Purdue and you get your PhD and you're doing all this really cool stuff, but at some point now you've got to leave university unless you're going to decide to be a full-time teacher, which is what I don't see happening in your brain here. You want to actually start solving, well, you are solving problems. I shouldn't say it that way. But you want to, I guess your brain is it time to go get a job and make some real money? Or do you want to stay in university somehow?
Yeah. I think if the route was clear to me at the time towards like tenure track professor, I might have chosen it. But the reality is at that time, and I think even now, just the competition for those sorts of positions is so high. Basically, what ends up happening is you do like 3 or 4 temporary postdoc positions, postdoctoral researcher positions, before you ever get a shot at like a tenure track professor position, which basically means you're in your like mid 30s up to 40, like still in sort of like low paying temporary like contract jobs. which like, if that's what you only want to do, then it may be worth it. But I heard stories of my friends going through like these positions and just having really bad experiences. And I was like, I don't know if I want to do that. And I want to do something technical and that sort of thing. But I didn't really know what. One thing about PhD programs in general is that they don't really, like, I had no idea what the opportunities were for a PhD physicist in industry. Like, where could I get a job? No idea. So my wife got a job in Chicago with Target in management, the retail company. And so I was like, well, I'll find something in Chicago. It's a big city. There's got to be someone that will hire me.
So in this 5 years that you're doing your PhD work, you meet your wife and get married in the middle of that. Okay, so you met her at Purdue. What was she doing at Purdue when you met her?
She was studying business management. Yeah. So she's hardcore into business, and that side of things. She's an entrepreneur now, so she runs a company, and has always had a passion for that kind of business side of things. And so, yeah, she was at Purdue at the time we got married, and then she got a job in management.
How does a physicist meet a business major at Purdue?
Yeah, big school. So two ways. One was we were both part of the same like Christian student union at Purdue, and so we met there originally, and like we're involved in that sort of organization. But then she also worked in the physics library, and of course I was in physics, so tended to check out a lot of books in those days.
Yeah. None of the books, how many of those books did you actually read, Daniel?
Well, yeah, you need 5 books, right? And so you go and get the first one on day 1 and the second one on day 2 and the third.
And how many times did you have to go before you finally asked her out?
Well, she was with someone else for like
bummer.
the first, I think, 2 years we knew each other, and then they broke up, and then I asked her out after that, and we dated for 4 months, and then I proposed, and we got married. So yeah.
Oh my, dude! Wow, you don't fooling around there. Wow, and she said yes after 4 months.
She said yes. Yeah.
And how long you been married now? Then you've been married.
It'll be 11 years in June.
Congrats, man. That's beautiful. So you don't know what you're going to do. You're graduating. She's graduated. She wants to go into business. She finds something in Chicago. Okay, keep going.
Yeah. So, like I say, I really didn't even have or know, like, I didn't know where to look for jobs. I didn't know what I could do. Someone, I forget how this part's a little bit unclear in my foggy memory, but someone told me that, hey, some intellectual property firms hire PhD people to like help them work with clients who have like complicated patents and stuff. So I was like, oh, that sounds like kind of interesting. It seems like cutting edge stuff that I could hear about, like maybe someone will hire me. So that ends up being like how I got a job initially. Was there's a IP firm in Chicago called Marshall, Gerstein and Boren, and they hired me as what's called a technical specialist, which is essentially like if you've got lawyers over here and you've got like technical like inventors over here, the technical specialist sort of sits in the middle and figures out, okay, like how can I help these inventors like parse out what they're actually doing and make it understandable to like lawyers on this side so that they can actually protect it. So it's kind of fleshing out all of the implications of a certain technology, working through all of the details. And yeah, that was a very interesting experience, super useful in many ways.
Plus, you had to learn what was patentable and what wasn't, because
correct.
That was so. This is 2013 when you moved to Chicago and take this. How long are you with this firm doing this IPO?
I think I was with them like 2.5 years, something like that, 2.5 to 3 years before.
How many patents were you able to help with? Do you know the number? Do you know how many you were?
I don't know the number. I mean, at any given point, we were probably working on like uh 5 to 10, and it's just like they're different in different stages, right? Like you send one to the patent office, it takes them a while to get back, so you work on another one, and so you got like, at any point you have your hands on sort of 5 to 10 or more different things, so lots of context switching for sure.
So what happens in 2.5 years at that point? Now we're talking about 14, 15, like middle of 2015, right? What happens?
At that time there was all of this starting to be all of this hype around what at the time was data science. This was like pre AI hype, data science hype.
Okay, time out. Where are you seeing this hype? You're seeing it in the patent applications that are coming in?
So there were more and more applications coming in that were related to like data science-y type stuff, meaning like predictive modeling or some sort of complicated data analysis. And I saw this stuff coming through and I was like, man, this reminds me a lot of this stuff that I did back in my PhD, back in other times when I was like doing computational modeling stuff. And so I was like, well, that's like really interesting. It's like there's this trend in industry where all of these skills that I had before are like being applied, but being applied in slightly different ways than I knew they could be applied. So that's what piqued my interest. Yeah.
So then what happens? You say, okay, I want to work on this stuff. Like, I just don't want to review it and make it better from a patent side. I want to work. So do you start looking for another job, or you start maybe soliciting the companies that are filing patents with your firm?
No, yeah, that would be a conflict of interest. So that, yeah, no, I didn't do that, but it was kind of interesting because like I knew all of these methods from physics, and I like the theoretical math side was not hard for me at all. But in industry, like everybody uses all of this different jargon for everything, and I had no idea like all of this jargon around like recommendation, pricing, like regression modeling, forecasting, like all of these methods, like I knew technically how to do them and it wasn't hard for me to understand them, but like there's just all of this jargon that started developing around like the data science world that I had no familiarity with. So I actually like I went through all of this material online, like online courses, online stuff talking about like all of this data science stuff. And I started realizing, hey, like I can do all this stuff. I just didn't know the words that they were using. So after a while, as like going through like the online course stuff, I got to a point where I was like, yeah, I could confidently apply for one of these jobs because like I don't have a doubt that I could do the stuff. And now I kind of know how to talk the talk a little bit. And so then I started applying for jobs, ended up getting, that's how I ended up starting into the data science stuff.
So what was that first job that you landed? It must have been a little nerve-wracking interviewing because you were doing patents, right? And Fortran and Math Lab and Mathematica were your experience. So I'm really curious what the first job was and what the tech stack was.
Yeah, so the first job was with a startup called Telnix, which is still around. Actually, they're doing really well now, in my understanding. But I joined when it was like, I think it was like 24-ish people. There was a startup in Chicago in the telecom space. So what they did was they routed phone calls and ported phone numbers all via API. And all of their infrastructure and their switches and stuff were in the cloud. So like a traditional telephone company, they got all their like switches like on-prem and stuff. So Telnix is actually a phone company, but all of their infrastructure ran in the cloud. They were multi-cloud, multi-region, and they could do like all of these telephony operations via their API. And so the idea is, yeah, you could like if I'm want to call my Uber driver, right? The Uber app can literally create a number for me to call them anonymously via API. I can call them, and then immediately after that, I can just totally tear down the number. It will never be used again, and everything happens anonymously. So
I always wondered how the Uber driver stuff kind of worked. So that's super interesting. So they could just invent a 7, or I guess 9, whatever that is, a 10-digit number.
Yep. Yeah. So you'd say, I want a new number in this area code, spin it up for me, and I want to send this text message, or I want to make this call, and so, yeah, I learned about all of that kind of telephony world a little bit. I mean, I'm by no means an expert.
Was your job to kind of like optimize the routing or something?
Sort of. So I worked primarily on, well, a number of things, but one of the big things was pricing optimization. There's this really interesting problem, which I had no idea existed, but like when you make a phone call, and your phone company has to complete that phone call, they could complete that phone call along any number of like underlying routes with any number of underlying vendors, right? And so there's like hundreds of vendors that could complete that call using their various infrastructure and network. And each of them have a rate for completing that call. Some are higher, some are lower, right? And so the trick, if you're a phone company, is how do I set my rate so that I can put enough of these vendors into route to make sure I complete the phone call, but I don't put it so high that no one wants to make phone calls with me, right?
Yeah,
so it's sort of, yeah, it's like almost like a game theory like thing, because all of these people are like responding to like shifts in rates, like all the other vendors are responding, right? So the trick was to figure out, what is the probability of all of these vendors actually completing the call, and what are their rates? And based on our profit margin that we want to make, what do we set our rate at so that we can make that profit margin and complete the call?
And what tooling? So this was all. What was your tool set for doing this? This sounds like spreadsheets to me.
So during that time when I was learning, well, I guess kind of like where I first got exposed to the data science tooling was in grad school. People were using like this Python wrapping around like Fortran code to run a bunch of experiments. And so I did a little bit of Python there. And then I saw when I was going into data science, a lot of people were using Python. So I started out using Python to do a lot of this stuff, but then the company, they ran all of their infrastructure, like I say, in the cloud, Dockerized with APIs, microservices for everything. And so quickly I learned like all these people in my startup are using this language called Go. And that's where I started dipping into like, hey, could I do some of this like data science stuff that I've been trying to do in Python? Could I do it in Go? Because that's what everybody else is using here. So like maybe I could do some of that. So it ended up being this kind of morph of like some Python here, some Go here, eventually kind of shifting to like a little bit of the both in various places.
I find it interesting because I think if you had a lot of Python experience at the time, you probably wouldn't have tried to do that, right? But since you had no affinity to what Python was doing, your brain said Go is as good as Python at this point for me. Like, I don't.
Yeah, and working with compiled languages and that sort of thing, like it was something I had done in the past, right? It wasn't like weird for me that like, oh, I need to compile this thing and then run like a binary. That was not as confusing for me. Plus just the like DevOps infrastructure that was there at the time, like I could write a Python application, try to deploy it, and it would create these like giant, like terrible to manage like Docker images that would be all bloated and take forever to build. And then I could write this thing and Go, and it would like deploy in like a few seconds. I'm like, well, I should do more of that, right?
So how long are you at Telex at that year? How long are you there? You got there in 2015. They're kind of a Go shop, which is super interesting. How long are you there for?
Yeah, so I'm there. I want to say like another 2 years ish. So I think it was around 2 years, and that was really a formative 2 years because that was my first experience with like software engineering process, right? Like how to do pull requests, doing code reviews, like this whole like world that I had no exposure to. I all learned it there, and they were very gracious to me and like sat with me and taught me a bunch of that stuff there as well.
And then what's your next move after that?
Yeah, I think it was after that that I started doing a bit more on the consulting side of things. So I think I forget when we first met up. It was probably pretty soon after that time. I started doing some side projects just on my own as like an independent contractor. But then we got hooked up not that long after that, like after GopherCon and other things, and that's the season where you and I worked together for a while on a variety of projects, and that as well like helped me kind of build up. Because previous to all of this, I had no like computer science software engineering experience, so all of this like process testing, code review, pull requests, version control, like all of that, I think during those years that I was working with you, Telnix, it like really solidified all those ideas in my mind, which was really really a blessing.
And then you started doing some training too around teaching people data science first, and then how they can even leverage it in Go, right? Which was cool.
That's correct. Yeah. Yeah, that was awesome. Yeah, after I started seeing, because I always loved teaching in grad school as well. I really like putting together curriculum and teaching. And so it was cool to bring a little bit of that back in. And I still do some of that even to this day, both at Purdue and some corporate trainings as well.
I remember you coming to me because a pretty cool company approached you, and it was an opportunity that you couldn't pass up. So talk about that. That was, so was that in 17 or 8?
Yeah, I was like 17. I'm really bad at this time
I am
stuff.
too, because so much happened in the last 5 years that it's hard to, but it had to be around 17, 18, I guess.
Yeah, so that company was called Pachyderm. They're also still around doing awesome stuff still. Their thing was really related to like, how do I run repeatable, robust, large scale data pipelines on containers, right? So on top of Kubernetes, how do I scale up not just like a bunch of containers running a service, but how do I bring in the idea of like a directed pipeline of operations where like I get this data from here that's processed through these stages. I then train a model over here, and that goes out to some batch inference. And like, there's all of these things connected, and all of them use maybe different tools or different languages, but they're all kind of like containers. So the idea is if I can string those together in a pipeline, a data processing pipeline, I could scale that up on top of Kubernetes and run all these really great reproducible data pipelines at scale. So they're still doing that sort of thing. They've also built a lot of other functionality related to that. But yeah, I joined them in a sort of as their first data scientist, kind of bringing in the data science side of what they were doing versus just the kind of distributed systems side of things.
I thought the biggest niche that I thought they had wasn't the pipelining, because there's other systems there that it was the data versioning, where you could run that again against the exact same data. Like it was GitHub in a sense for data and data modeling.
Yeah, it's a really amazing system that they architected, and it's not just like they don't just run like Git large file storage on top of like files. It's actually their own data versioning system, which is incredibly robust and scalable and performant. And it's really valuable because like, especially in the data science world, if you're running like an AI model, the output of that model is tied to the code that it's written in, but it's also tied to the data that you train the model on. That's actually like the most important piece. And so it's one thing to like version your code in your model, but if you can't tie it in the lineage back to the version of data that was used to create the model, and something goes wrong, or you want to update your model or you want to improve it, it's really difficult to do that if you can't like have that data lineage.
You can't reproduce it. You can't go back in time and reproduce it without versioning the data.
Which in some cases is like a regulation now in certain like countries and jurisdictions. Right?
Wow. And their platform is written in Go. So
their platform is written in Go on top of Kubernetes.
So your data science background with the Go kind of got you, kind of landed you there.
Yeah, it was a niche. Yeah.
Yeah, as well. But you weren't there very long. You were there for a year and a half or something.
Yeah. There for a year and a half or so, and that's when I got the opportunity to build this new team at SIL, and that's where I've been since. So it'll be 4 years at SIL in June-ish, I think.
How did you get introduced to SIL? Had you heard of them prior to that? Or however you met them, were they on your radar?
No, they weren't on my radar. Actually, I think in general, SIL is like a confusingly marketed organization that like most people don't have any sense that it exists. Part of that is like a historical thing, but hopefully that's getting better. But yeah, I didn't know that they existed, and I was really having a passion at the time, thinking about like seeing so much of AI and data science develop, but then like increasing numbers of ways people were using the technology and maybe harmful ways or ways that, were maybe not the best. And so I was really thinking more and more over time about like, who are those like groups out there that are really applying this technology for good? And is there a chance for more of that to happen? And it was through some connections, both through my church, through some friends. They had some connections to some people working at SIL, and they basically said, "Hey, you would really get along with these people because they're like very SIL has traditionally been a very academic, scholarly organization doing linguistics type of work around the world. And so like they love PhDs and they're doing more of this computing stuff. They have these new products. And so, yeah, that's where I got connected into SIL. Someone introduced me to a guy named Steve Moitozo. He was at the time the chief innovation officer at SIL. He's now on the leadership team at SIL. And so he's the one that kind of provided an on-ramp for me into that and said, hey, I think we can do something really interesting together here.
So a few things there. But from the time that I met you, you were already a great personality on stage, teaching and sharing. So does SIL allow you to continue to do that? I know that you have the podcast. I know that's with the changelog people. I imagine they're okay with that. I want to talk about the podcast, but does this role that you have there, is it just pure engineering? Are you just solving problems, or are you also able to extend your personality?
No, I think a lot of what it's been over the past 4 years is now doing a lot of that kind of advocacy and evangelism work, both internally to SIL and externally, because SIL is a huge organization. We actually have I think it's between 3,500 and 4,000 people working around the world. And so to say like, okay, we're going to really intentionally dig into this new technology of AI and like make an impact there. It took a while to get that momentum going. And there was a lot of sort of, innovation work within a large organization is very difficult. And it took a lot of work to kind of like put the pieces in place for that. So I think initially it was a lot internally, just kind of making relationships, helping develop like the vision for what this could be. Now I think that's shifting a little bit externally to where I mentioned I'm, going to a conference here in a couple weeks, but there's been more and more opportunity, I think, to whereas before maybe I was speaking more at kind of like cloud native Go type events. Now there's hopefully an opportunity for me to step into more like AI type events where maybe people aren't thinking or they just have no idea about like the ways in which this technology is like increasingly marginalizing people around the world. And so to have someone come into that space and in a gracious, welcoming way kind of help people like start thinking about some of these things, that's part of what I hope to bring to those spaces.
You're the perfect person to be able to bring awareness to the problems because you have the engineering chops. Nobody's going to talk over you on the engineering side. And the personality you have allows you to, it's like very warm and welcoming. So I would imagine that's going to be great for them as well. The more you're out talking about the problems and the solutions. Talk a little bit about your trip to that conference and how. Yeah, I think it's a nice story. I want people to hear it.
Yeah, you mean the Dublin conference coming up? Yeah. So there's kind of maybe 4 or 5 top tier research conferences in the AI space. There's an increasing number of them, but these are conferences where a lot of researchers from like Google, Microsoft come and present, but also a lot from like universities. There's and this is one of those conferences. So it's called ACL, and there'll be a bunch of different like talks on all sorts of subjects from like dialogue systems and chatbots to like machine translation to like these large language models, which are driving like a lot of innovation in all sorts of arenas. But the theme track this year, which is pretty cool, it's actually focused on endangered languages. So the NLP community has actually started to recognize, hey, if we don't like put some focus on doing things in languages other than English and Mandarin, then we're really causing some problems in terms of how marginalized these languages are, and also getting those language communities to participate in this work. And so it's really cool to see that theme track there. And we're presenting this paper in the theme track on endangered languages, related to using like very small amounts of data to do interesting to build interesting applications. So that's a space we work in a lot, is using very little data, because we often don't have a lot of data for these languages, to do maybe things, doing a lot of trickery to do things that maybe we couldn't otherwise.
Sounds like you're building Rosetta Stones for these languages in case they disappear or something.
Yeah, it's true. And I think from the SIL perspective, we're very passionate that this is like a two-way thing, right? Like, and you've probably, in all of your travels around the world, you've seen this, right? These language communities or like local communities around the world, they have so much to pour into, like, to us, like so much that we can learn from them in terms of their perspective on the world, how they see certain problems, how they solve certain problems. Wisdom that's built up in their communities. And so we're really passionate about thinking about this, not like we just want to get all of Wikipedia into all of these languages. Like that's okay, that's like great if we did that. But having it to where, like you were saying, like the whole Babelfish or like Rosetta Stone idea, where like, what if someone could be on this podcast speaking like Central Siberian Yupik, and like we could understand them and they could contribute to the global conversation. That's really like the type of flourishing that I'm really excited to see. So
what's holding us back from the Babelfish in my ear? Is it compute power right now?
Yeah, it's like a few things. I think one of the things is just related to data, right? So the real driver of this technology is what data do you have available to train the models?
Locally.
Well, even like there's sort of a two-stage process with a lot of these models. You do the kind of training to get the model ready, and then you do like inferencing, which is like just give me an input and I give you output. Give me an input and I give you output. And so in that training phase, you need a lot of examples to work with. So like speech to text, for example, you need a lot of samples of audio with the corresponding text. And the reality is that this data in a sort of like publicly accessible, large scale form does not exist for most languages of the world.
Oh, wait, I'm gonna stop you for a second. Google Translate. Let's just talk Spanish for a second, okay? Google Translate isn't that bad with the Spanish. It is good enough that even if the grammar feels off, you understand.
You can understand
what they're asking.
Yeah.
So from my perspective, if we just focus on Spanish, that problem is solved. It's good enough, right? And IVRs have been around for interactive voice response systems, which I hate, right? Press 1 or say this. Like for English, that stuff is good. So why can't I have a device, even if it's specific for Spanish today, working in my ear with the bandwidth I have in the US, right? 5G gives me a gig connection at my ear. So what's stopping me from being able to talk to my wife in Spanish or English to Spanish, right? My grandmother, let me say it, her mom only speaks Spanish. What's stopping me?
Yeah, I think part of it is like so there's a few elements here. You're right that like for the very like major languages of the world, a lot of this data is now not the problem. The data exists. So then what do we have? Well, in order for that kind of system to work, this whole speech to speech thing, right? Like I talk in one language and the speech comes out in the other. You're looking at actually at like a few different tasks, right? You have taking the speech and transcribing it, then you have machine translation, then you have a synthesized voice, right? So there's probably like 3 or 4 different models that are at play there, right? And if you want good performance in each of those tasks, those are big models, which means they don't respond instantly, right? And the only way to get them operating in real time is to run them on specialized hardware. So it's not so much that you can't do this sort of interaction in a batch like way where there's some latency, but the true real-time bit, it is sort of like a size of model plus specialized hardware problem, which is a bit, it's a bit hard to juggle. There are devices now, if you look up like this little kind of gum stick size device, they kind of look like an iPod Shuffle. I don't know if you remember those, where you can like hold it down, speak into it, and let go, and it will repeat what you said, but in a different language.
I gotta look for that.
Yeah, that's like doable because it's also not real time.
Dude,
right?
I would live with a 10-second latency right now just to talk to my mother-in-law, right? I can't have a conversation with her.
Yeah, look it up. I forget the names of them. I know that they have them for like Mandarin and Japanese, Korean. There's probably one that's for Spanish, but yeah, it's sort of a combination problem.
I could live with that. Even that stick I could live with, because if you had a family get together and I want to have a conversation with mom, right? Who cares if she can't hear it for 3 seconds after I stop speaking? I really don't care. That's what I want. I want to live long enough to experience that because of all of my traveling. Even if I can't travel anymore, I'll find somebody. But that's the tech I want. If I was Elon Musk rich, I wouldn't be buying Twitter for $40-something billion. I would fund that project right there.
Yeah, it's I think I saw, this was like 3 or 4 years ago, I saw Eric Schmidt he like posted, I forget if it was on Twitter or somewhere, he's like, speech is a solved problem. And the reality is like, we still don't have that device that you're talking about. And so like, there's like language and speech is a very complicated problem, both on the computational side and on the sort of modeling side, where it still presents a lot of challenges to solve, even for major languages, but especially for these sort of lower resource languages.
Yeah, and my wife, right, can translate between the two languages, like to the point where she even knows what euphemisms to use or like the right words to use, right? Like shows you how powerful your brain is, But my favorite is when she's like, no, that doesn't translate. Like I'll translate for you, but there's a joke in the vocabulary of the words. And
there's a very famous saying, I forget which philosopher said it or someone, it's like every translation is, or every translator is a traitor, right? Because there's just like when you translate, you have to make certain stylistic and other decisions, and certain things, whether it's rhetorical questions or jokes or whatever, it's not representable in the same way, right?
Yeah. It doesn't translate. So I've heard that a lot. All right, Daniel, our time is pretty close to being up, but I did want to ask what sort of stack the projects that you're working on are using. Are you using Kubernetes and containers? Are you using Pachyderm? Are you using it's interesting to me what the general stack is for the projects over there. Maybe it's R, which is a programming language I've never looked at, but it always comes up in data science.
Yeah, so there's sort of three sort of scenarios that I think about. The first is like, how do we experiment and do the research to get the models we want to run in production? That's like a first bucket. The second is, how do we repeatably train and process the data we need for those models? And the third is like, how do we run those models in production, like in actual applications? In the first scenario where we're doing the research, training the model, we're using a lot of the sort of Python AI stack running on, we have even like an on-prem GPU server that we queue up jobs on. It's a very like high performance computing type of scenario, like job queuing, long running jobs, lots of failing jobs. And so that's like a research environment. The second environment where we're doing a lot of data processing, we do actually use Pachyderm for some of that pipelining, where we get version models or version data sets. We're updating those data sets over time. That's running on top of Kubernetes. And then on the like application side, we are using Go for like APIs that actually have our models embedded in them, for all the reasons that we love Go. And those are typically run either we might like wrap a model up and run it serverless, but a lot of times we're wrapping it up within an API application and running that on, for example, Kubernetes. Yeah.
Wow. All right. So since you have a podcast all about machine learning and AI. So what can we expect to see in terms of new systems, tech, hardware, I say, over the next 12 to 18 months? What's showing up on your radar screen right now with your podcast?
Yeah, I think that one really interesting thing to watch for is an increasing number of what are called multimodal applications. So these would be applications that process like multiple types of data at the same time. So traditionally, like you have a model that processes audio or speech, you have a model that processes a different model that processes text, a different model that processes images. But there's a lot of like problems that are multimodal. So like image capturing, you get an image in and out comes text, right? A totally different type of data. Or maybe you're processing your voice, but also the video of the person to help like process the voice. So I think you're going to see a lot more of these kind of multimodal applications where you're processing multiple types of data with even the same model. You're also going to see, I think, an increasing amount of like data and models shared, pre-trained for like commoditized use. If you look at a platform called Hugging Face, you'll see the scale of this. Right now, that platform has like 30,000 plus public models that you can just pull down and use. And so it's getting much easier and easier and easier for me as a software engineer to just pull down a state-of-the-art model, plug it into my code. I'm running and doing speech recognition, like boom, done. So there'll be a lot more of that as well.
What about, I remember when Google released their hardware, was that Tensor? I don't.
TPU, yeah, Tensor
TPU.
Processing Unit. Yeah.
It was like this big deal, right? Because Google released hardware that was specific to their software, I guess. Is there any like hardware or improvements in hardware that you've seen coming up?
Yeah, so I mean, the biggest players would be like NVIDIA, for example, with their GPUs. They just released a new architecture called Grace Hopper, which is extremely powerful. I think one of the interesting things that we've seen over the past couple of cycles with this hardware is increasing like virtualization. So with the GPUs that we use now, we can take a single GPU card and split it up to 7 different virtual GPUs and run jobs in parallel across that same processing unit. And so it's sort of like you can adjust how you use the GPU based on like, are you going to run a lot of small jobs? Or are you going to run like big jobs and you want to tie cards together? So there's just a lot of more flexibility in terms of combining and slicing and dicing hardware accelerators than there used to be, where you just had like a single card. It had a certain amount of memory, you run on it or you don't run on it.
But these aren't video cards, right? Because I started hearing reports that video cards, gamers are having a hard time finding video cards because, Daniel, you're buying all the cards up to do AI, right?
So on the GPU side, they're definitely graphical processing units. But the ones that are used in the enterprise, they're mainly geared towards enterprise, either AI applications or rendering applications for like production, sort of like film, video, image production. But the latest generation that I'm talking about, it is very specifically geared towards AI. Like it probably wouldn't like be that great for your Call of Duty like game or whatever.
That's what I'm saying. These cards don't have a monitor port anymore, right?
So yeah, some of them do. Some of them are like integrated in different ways, and you can. So I think some of the confusion is you can use consumer consumer GPUs that you'd use for video gaming. You can use them to accelerate your AI applications. But then there's another sort of set of units that are really enterprise grade, geared specifically towards AI, that probably wouldn't go the other way. Like you wouldn't take one of those and run it on your like gaming rig.
I see. And NVIDIA's like, they kind of fell into this space then, I guess, right? Because they're manufacturing these GPUs. It's their design.
Yeah. They're like definitely the biggest player, but you'll see a trend in the next couple of years where there'll be a lot more competition. One of those is called GraphCore. They have a IPU, they call it, and it's really seeing a lot of adoption as far as I can tell. So there's an increasing number of competitors that are making specialized hardware for AI applications.
So here's my last question. Why is the AI ML algorithms so floating point heavy and not integer based?
Yeah, good question. I think that most of the applications that we've seen AI models applied to, for example, if you think about like the classic, like I'm going to predict that this image is like either a cat, a dog, or a horse. You've got 3 classes. And what you do in such a case is you don't like output like 0, 1, or 2, like integers for those. For a variety of reasons, including like that also like brings out some ordering, and like 2 is bigger than 0, more so than 1. And so it has various numerical implications. what you do is you actually predict a probability for each of those classes. Like I'm 20% sure, 21.2% sure this is a cat, and et cetera, et cetera. And those probabilities and what those are built on are, represented best by floating point numbers.
Yeah, because my brain says, okay, we don't store money as floating point. We store money in pennies, right? We still use integers. So I imagine if you made the scale large enough, there would be, this is what we complain about with Celsius, right? I like Fahrenheit because the difference between 70 and 71 is small enough where you can still feel it, but the difference between like 25 and 26 Celsius is huge, right?
Yeah. And you've actually seen a trend like from floating point 32 to floating point 16 to like smaller and smaller, because like when you do that, it does make your like training much faster. And in certain cases, you're able to do more experiments and scale things further because like, floating point 16 versus floating point 32, like you can store so much more like data and model parameters in your GPU than if you're using like the larger precision. So there is an increasing trend towards that, but it's still mostly floating point. Yeah.
Interesting. It's okay. That's fair. All right, we are out of time. Dude, I feel like this hour plus went by way too fast. So, for anyone listening to this show, if they wanted to reach out and talk to you after, and we'll put this in the show notes, but what's the best way for people to reach you?
Yeah, they can find me on Twitter. I'm DWhiteNA. And then, of course, people can reach out to me at my SIL address, Dan_Whitenack at SIL.org. If you want to check out the podcast that I do, you can go to changelog.com/practicalai. And yeah, I'm on a variety of Slack channels. My Slack is full of channels, so I may be around, and I'm in Gopher's Slack and other ones as well if you want to reach out. So
that's brilliant. All right, Daniel, thank you again for all the time that you spent. This was really interesting stuff. I didn't even really know about SIL. Is it SIL or SIL?
SIL. It was originally Summer Institute of Linguistics, but there's no more a Summer Institute. But we kept the SIL for whatever reason. Yeah.
That's fair. So yeah, I didn't even know. And it's really interesting, the stuff you're working on. So thank you again. So this is Bill Kennedy and Daniel Whitenack signing off from the Ardan Labs podcast, and hope to see everybody again real soon.